Mata and I shall be presenting the rest of the black box system testing. Human System Interface Testing, or HSI for short, considers the use of input devices controlled by humans and output boundaries between the user, operator, and the system itself. HSI is used to determine the acceptability by the end users. It is composed of two parts: the proper functioning of interfaces and the ergonomics of interface activities. Proper function of interfaces means all interfaces carry out their intended actions for their intended purposes. A simple example of this would be when you click a link on a website and it takes you to the designated link on the web page. Ergonomics focuses on people's abilities and limitations and the actions that must be done to use or operate the system. The goal of ergonomic design activities are to optimize the effectiveness of human activities that work and are carried on, which in a sense means trying to make the interface easier to understand and use with less tedious actions. HSI Human Input Testing. There are two steps needed to test a human interface. One must first validate that the system responds correctly to the proper commands or sequences, and second, one must verify that the system recognizes, tolerates, and properly handles the operator errors. Test cases should also be created with inputs and user input errors. In general, we test the input tolerant properties of the system by verifying that the system is consistently able to detect and handle proper user inputs. The system must also be able to detect user input errors and inputs from propagating beyond the HSI area. They should indicate the existence of the input error to the user and suggest about the nature of the input error and how to correct the error. The input must also permit the user to correct his or her error and completely remove the erroneous input from the input interface. HSI Human Output Testing. HSI output testing involves generating and executing test sequences intended first to verify that the system meets its specifications, and second, that humans react properly to the output information. Testing human output interface is dependent on each system, so each output is only for its intended devices. It closely entails the interface at which inputs are entered, such as the actual display of the interface and what is allowed into the system to be seen. So for our system, we would have a text box that shows the user to enter his information, and once the user starts typing in their information in the line, the characters that are already in the text box should be disappearing as he enters his name. HSI Human Input and Output Testing continued. Here are some common HSI input and output practices. The first one being violate data type or size, which is putting specific characters where they don't belong, such as putting alphabetical characters inside a numerical only text box. The second one is violate user input restrictions, which would be attempting to violate the restrictions on the user, such as trying to look at an unauthorized file or do unauthorized actions. The third one is skip mandatory fields, which would be attempting to skip fields that are required, such as trying to skip a login. The fourth one would be inundate system, which would be inserting too many characters, such as typing in a password that only requires 9 but you put 10. And last would be generating unexpected sequences, which would be activating switches in unexpected sequence or random error, which would be like touching all the keys at once. Black box high volume automatic random testing, also known as statistical or stochastic testing. The concept of injecting large quantities of random inputs into a system in order to see its behavior. Automatic random testing is meant to evaluate the system performance under unexpected conditions over time. Such high-volume testing involves a long sequence of tests where random input values are presented to the system. However, this is really risky due to the lack of specific failure outputs. Automatic random testing continued. The cons of this are that the tests are not very powerful. However, they are meant for long-term testing such as memory leaks, stack corruptions, and accumulation of data that over time cause system failure. The tests, however, are inexpensive and do not require detailed system under test procedures. It can assess the stability and reliability of the system by mimicking its behaviors over huge periods of time. This means that discrepancies in the specification may be missed and only obvious faults such as the system crashes or certain error conditions can be found. Another concern for this method is that random test data must be restricted to only external conditions that could possibly occur, or valuable time and resources would be wasted. Black box high-volume enhanced random testing. It was created to alleviate the problems associated with automatic random testing. In an enhanced random testing, data is structured compared to automatic random testing where they just dump a whole bunch of input values. Enhanced random testing tries to associate the inputs with the outputs to help make the test much more beneficial due to the lack of redundant tests associated with automatic random testing. Common forms of enhanced random testing. Parameterized random test data generation, which is where you place parameters in the data input in order to control the range and characteristics of the random values and their outputs. Directed automatic random testing eliminates the use of written test drivers and automatically generates tests through the interface. Specification-based random testing combines the random testing with formal specifications, as seen in the diagram below. Common forms of enhanced random testing continued. State model random testing uses the finite state machine testing test cases to create a unique output to see its transition between states. Random testing of interrupt-driven embedded system testing. Tests that involve generating interrupts at random times to try to make sure that the system doesn't crash. The diagram on the far left is an example of interrupt testing where the system is in a default state and hits an interrupt which causes it to go into an emergency state. The state is then supposed to go to a restore state and then back to the default state. However, if it fails, it will then stay in the emergency state. Common forms of enhanced random testing continued. Regression random testing. The set of input and output data sequence of the previously passed tests are then edited so that they don't match the previous data. They are then resubmitted into the system in a random order to check against the expected actual outcome. Random testing of integrated circuits is where they carry out in numerous types of analog and digital integrated circuit hardware. Overall, VVT testing is an integral part of the system. It is a process that ensures the system is developed according to its original requirements. It is composed of white box testing and black box testing. White box deals with the internal architecture of the system, while black box deals with the external interface. Some white box techniques that we are going to utilize are code coverage, in particular the software testing phase, that utilizes statement, branch, and conditioning, as well as information interface testing. As for black box techniques we are going to use boundary value testing, finite state testing, and human system interface testing. This concludes our presentation. Thank you for your time.